Hey students, Mr. Buxton here. So you have come up with some statements comparing two variables that are inequalities and are interested in being able to graph these inequalities in two variables. So this video is going to explain the steps to graph an inequality in two variables. And I've broken it down into 3 steps. Step 1 is going to be determine the boundary. And we're going to do this by changing to an equation. Step 2 is going to be determine if the boundary is included. And step 3 is going to be to determine shading. And we're going to do this by testing a point, and specifically a point that's not on the boundary, but you'll see that in a second. All right, so let's look at an example. And the example that I have for us to start with here is 8a plus 10p is less than 120. So it doesn't matter mathematically whether a is on the horizontal or vertical axis, but just so that we're consistent, I'm going to have us as a class use a convention that we're always going to put the variable that shows up first in the alphabet on the horizontal axis. So I'm going to put a on this axis and p on this axis. So step 1 of our graphing a inequality in two variables is going to be to change it to an equation, right? So we can see right here that it's an inequality. So I'm going to take that and I'm going to rewrite it as an equation. And to graph that equation, we could put it in slope-intercept form and use the, in this case, the p-intercept in the slope. Or we can come up with 2 points on the line. And in standard form, it's a nice, quick way to graph a line. So this is a linear equation. So 2 points are on this. If we put 0 in for a, that would make p 12. And if we put 0 in for p, that would make a 15. Right? So those are 2 points there, and then we can draw the line that goes through those 2 points. So 0, 12, 2, 4, 6, 8, 10, 12. It's going to be a point right here. So this is the value 10, 2 higher than that. And then 15, 0, 2, 4, 6, 8, 10, 12, 14, 15. So there's a point here, 15, 16, 19, which would make this 20 if we're counting by ones. So those 2 points, 0, 12 and 15, 0 are 2 points on our boundary. Step 2 is going to be to determine if our boundary is included or not. So because our inequality is just less than, it doesn't say less than or equal to, that means that the boundary is not included. So when the boundary is not included, we're going to use a dotted line for that boundary. So I'm going to put a dashed line. That goes through those 2 points, okay, meaning that we're not including the points that are on that boundary. And then step 3 is going to be to test a point that is not on our boundary. So the point that I'm going to test is 0, 0. So we can see that 0, 0 is not on our boundary line. And when we test 0, 0, we're going to do 8 times 0 plus 10 times 0. And we want to know, is that less than 120? So 8 times 0 is 0, and 10 times 0 is 0. 0 plus 0 means the left side is 0. And is 0 less than 120? And our answer is yes. Therefore, so these 3 dots is a shorthand way of saying therefore. Therefore, 0, 0 is a solution. It makes our inequality true, so it is a solution. And so because it is a solution, that point is shaded, as is everything on the side with that point. So if we found that it wasn't a solution, we would need to shade the other side. But because it is a solution, that means that our graph is everything below that dashed line.